All right, hey everyone, and welcome to week 46 of Chill Kernel Hacking for Fun. This week we are continuing with Lab 4 for another stream. We've been working on this for like months at this point, but we're in a pretty good spot to work on exercise 12, copy on write fork from userspace. Let me start the music quickly. I just realized I forgot that. Where's my sound settings? Okay, so hopefully we got some music going. I'm going to test the chat. I'll get my Miro going. Good. Last week, we tried to start all of this copy on write fork from userspace stuff, but I spent the whole stream understanding recursive page tables. But now that I understand them, we can make a bit more of further process. Recursive page tables, at least this coursework didn't really refer to it as such, but that's like this term I've seen around. The recursive page directory is what we did. But we're doing something kind of different. In like proper recursive paging, it's something along the lines of setting the last entry in the page directory to point to the page directory. But you can access any page table through a fixed address in memory. And you can access the page directory through a fixed memory address. So I don't know. This is basically what we are doing, though. We are employing recursive, this recursive paging structure, where you point a page directory entry to point back at the page directory itself. Cool. So with that, I am going to hop back into my editor and let's see where we want to continue. So if I recall, yeah, so we need to implement fork, dupe page, and page fault in lib/fork.c. And this is where we were, right? So we're implementing fork, and that's kind of what I started on last time with a bunch of the easy stuff, which I copied from the dumb fork program, which is over here. I copy and pasted just this. So we need to register our user space page fault handling function, which is called page fault. We need to do an exofork to make a blank copy of the process, or rather, it's not like a blank. It's just it's a blank process. We create a blank process as the child, and if we're the child, we return. Otherwise, we do the copy on write fork. And here's what I sketched out so far. Before I read that, I want to refresh myself on what this thing says. So it tells us kind of what we need to be doing. Yes. Also going to basic control flow, install page fault as the handler, exofork for each writable or copy on write page in the address space below utop called duppage, which should map the page copy on write into the address space of the child, and then remap the copy on write, the page copy on write, in its own address space. Apparently the ordering matters for some reason. I couldn't think of why in the amount of time I wanted to spend on this last time. Maybe it'll come to me later. My guess was something related to concurrency and race conditions. Maybe if you do it this way, where you map the page copy and write in the child and then remap it in the parent, that prevents some kind of race. I'm actually not totally sure what the alternative is to doing this. Marking page cow. Like marking the page cow in the parent and then marking the page cow in the child. Yeah. Maybe that'll become more apparent later. Duppage sets both PTEs so the page is not writable, and to contain PT cow in the avail field to distinguish copy and write pages from genuine read-only pages. The exception stack is not remapped, it's actually freshly copied. Fork needs to handle pages that are present but not writable or copy and write. So just normal read-only pages, in which case those just get trivially mapped between processes without any particular fanfare, I believe. Okay, so duppage, which does this stuff. So here's what I sketched out so far. Also, let me just make sure my my build works. Let me just quickly got that. Okay. So it doesn't really even build. How did they? What is going on? Is adder is a uint8 t pointer. Interesting. uint8 t pointer. Just do another yo in the chat. Okay, so that's that build. But here's what I kind of sketched out. It's saying for each page in the process, for each writable or copy and write page in the address space called duppage. That part is actually a little bit interesting to me. Currently, that's not what I'm doing. Currently, I'm just blindly iterating through the entire address space in the child, basically, based on these hard-coded addresses. And I kind of get the sense that I'm not supposed to do that. So maybe I need to some helpful comments here. Hint, right, okay, yes. Then mark the child as runnable and return. Okay, copy address space and set it to the child. Use UVPD, UVPT, and duppage. So this is a hint. I think I need to be using UVPT and UVPD here actually. So I'm just going to give this a try. So the rough sketch here is we're going to iterate over every page in the address space. And then what? For each writable or copy on write page. So then we need to check, is it writable or cow? And how can we do that? We can, I guess we can look up the page table entry by basically, well, we get the page frame number, which we get by shifting over the adder. I'm wondering what type. I'm just going to make an int and call it, just do this, pfn. And this is going to cause a bunch of warnings because why? Because you can't shift, oops, you can't shift a pointer. And then why is this complaining? Why is this unidentified? We are including memory layout.h. Something, so if def JOS user, what happens if I actually try to compile this? It actually compiles. I don't know what this is this actually, is that a false positive? Okay, I get a compile error if I do that. Man, that is annoying. That's a false positive warning. UVPT is undefined. That's annoying. What's up, Yoso Kim? Thanks for joining the stream. But yeah, this is my understanding of how I use this thing. And then if t writable, or pte and pt cow, what's up, Wabat? Hello. Welcome to the stream. Something, this is all just kind of me sketching things out. And the question is, what happens if it's just a normal readable, read-only page? So the point here is to make a cow copy of the process. And okay, I'm just going to draft a couple of thoughts in Miro quickly. What is today's date? The 15th. It's number 46. And so I'm just going to draft a couple of thoughts with a sticky. So if it's read-only page, that means we map the same page read-only in the child, no cow bit in the PTE. And if it's a read-write page in the process, we map the page read-only in the child with the cow bit set in PTE. Or maybe I can structure this a bit differently. I can say and then I can do cow bits. We'll say the read-only page is read-only, and this is 0. What's up? Oh, what's up, Ankit? Hey, what's Wabat? This is a custom kernel, but it's not like totally from scratch. I'm just following this coursework in this course. But yeah, it is kind of a custom kernel. Yep. Recommend you. Thanks, Yosukim, for recommending me. What's up, John? Nice to see you again. Actually, John, while you're here, I am planning to host a hobby OS development meetup at CCC. I don't really know how to do that, but I made something called a self-organized session on the website. And yeah. Hey, University recommended music. Nice. I'm just playing this lo-fi hip-hop playlist. Yeah, it's apparently too late to make an assembly, actually. But you can make self-organized sessions still, which kind of, I don't really know what that means. But I made one. I registered one anyway on the website. Okay. And then the thing that's kind of confusing, it says for each writable, yeah, Wabat's most of myself, thanks for the link. Yeah, totally, no worries. So a process, right? So a process can have copy on write pages actually. For example, if we have the original process 1, it can fork itself into process 2, and maybe it had some writable pages, and when the fork happened, those pages became copy on write in the child process. However, then the child process can actually fork itself into another process, and it's possible that those copy on write pages in the child in process 2 have not been faulted in yet, and they are still read-only pages. However, they do have the cow bit set. So the correct thing to do there is when we fork another process, we need to maintain that cow bit. And so that's kind of why there's this distinction. A page can be read-only, it can be normal read-write, or it can be read-only with the cow bit. And then these columns represent what the page tables should look like in the child. In the case of read-only, it's very simple. The child gets read-only pages. If it's read writable, it's also, well, if it's read writable, then they become read only in the child with the cow bit. And I think this simply the same is true actually. So if it's read only page, no cow, in the child it becomes read only, no cow. Very easy. If it's read write, it becomes read only plus cow, and if it's read only plus cow, it stays read only plus cow. So this is kind of my understanding so far. So next stream will be on IPC. Honestly, I have no clue what the next stream will be on, but actually, I mean, if you're following along with this, technically yes, IPC is what's next on the agenda. However, that depends on me finishing this part in this stream, which maybe I will do, maybe I won't. We'll see. It'll be a mystery. I hope I can get through it, but I am not sure. But I think I'm pretty optimistic we can get through this. Okay, so based on that rough understanding, I can implement some logic there, but my question is kind of this duppage thing. Map our virtual if the page is writable or copy and write. The new mapping must be created, copy on write, and our mapping must be marked copy on write as well. And I still don't know the answer to that question, but I have a guess, which I wrote down here. I'm still a little bit unsure how they want me to structure this code. Like, the page is writable, then the new mapping must be created, copy. I guess I'm just going to follow along. So this function takes in a page frame number, and it seems like it has to do these checks though. So that's kind of why I'm not sure I need all this stuff here. Like, my kind of dumb idea is just to call duppage on everything, and then just handle everything in here, which I'm kind of not sure that's what they were really intending. But I will just give it a try. Okay. So, but I kind of need all these things that I had before anyway. I mean, basically it's a similar piece of code. So here, I don't have a Clang format. Okay, so, and it's time for a quick 20-second break to stand up and stretch. Be right back. Also, my friends gifted me this plant recently. I'm gonna include that in the side here. Yeah, my friends gave me this plant. It's pretty nice. Put it off to the side right here. Okay, nice. So basically, I'm just going to kind of do this in a very dumb way, I think, to start out. So I'm going to first check for the simplest case if it's read only and no cow bit. So I'm going to say if PTE and PTE this, I guess. And so if it does not have the writable bit and it does not have the PTE cow bit, also quick. Oh wait, that's probably an X. Wait, no. PTE cow, where is that? That's oh wait, that's declared here. PTE cow marks. PTE avail is this broad section of bits, and then if I just quickly go, wait, do we have, yeah, just to quickly refresh on this. So hex 800, we have 1 bit, so 8 is going to be the highest ignored bit. I think we're storing the PTE cow there. Funny to read you worked in infosec multiple years. I currently work in that sector. Have you switched to systems programming full time? If so, how have you been finding that switch? Asking for a friend. Yeah, I have. I work in the music technology industry now. I wouldn't say I do systems programming like really in what I'm doing right now, really. But I program production software in C++, and it has some systems elements. It is a lot of normal application programming though. But I've enjoyed it a lot. I find it really nice to feel like I understand a bit more about how production software is written, and that's not something I was learning as a security researcher, basically. So I've been liking it. It's not for everyone, but I don't mind being a normal software engineer. Also, it also has a lot of not fun parts, like writing unit tests and maintaining unit tests and all this stuff. But I don't mind it. Yeah. Okay. Thanks for asking. So yeah, read only and not cow. Then simply remap the page as read only in the child. And let's see how to do that. I sort of don't remember all these different syscalls. Also, kind of annoyingly, we need to re-extract the address. Pointer T. Something like this. It like feels a little bit, I think we need this because these APIs require passing in a pointer. So it's like a little bit annoying that we need to shift this thing in and out. It's also annoying that this thing doesn't know about this symbol. I think that's because of this if-def. What if I comment out the if-def? Then this thing goes away. So, yeah, it's all about the if-def. Somehow, JOS user. So somehow the build process is aware of JOS user. We pass that in to the user C flags. And I actually have no clue where these things are coming from. Like, it's very useful. I don't know what extension is providing these helpful hints, but it's not aware of my build system And so it's not aware of these if-def definitions, which is why it's giving this false positive, unfortunately. So I guess I'll just have to live with that for the moment. And I had it in mind that I needed to recruit a build system engineer to help me work on this, because I just don't have time to deal with all these random build things, because I have the core kernel to work on. But yeah. Okay, but anyway, back to this. So it looks like here are the system calls we're going to use. We can allocate memory in a process with syspage alloc. And it deleted your link. Damn, I have some Streamlabs stuff going on. I think it's meant to protect against spam. Compile DB. Compile DB. Is that like a compile commands.json kind of thing? Yeah, perfect. For make-based build systems. Oh, awesome. Is this easy to use? Generate. This looks pretty easy. Thanks, I'm going to save this for later in the Miro board. I deleted my message too after, it seems. Point and shoot, super easy. Then the next question is, how do I pass that to compile? Commands. Value to set if. I guess I'm using the C. All right, YOLO. Let's do this. Pip install compile db. YOLO. Is install user still a thing? Is pip or is pip user? Good Lord. JAWS. Pip install compile db. All right, what do? You do make clean, and then compile db make. Sick. What happened? Now I have a compile commands.json. Okay, all right, word. That was pretty easy. So now, did that fix it? It seems like no. So maybe the value. Also, yeah, what? Am I using the C? Is it called C/C++ or something? Yes, I think that's what I'm using. Auto update. So, do I just say compile? Yeah, I usually use ClangD at work also. I just didn't set that up. Okay. I wonder if that works. Did that just work right now? So now the squiggle is gone. If I break this file path, does it reappear? It reappears. Awesome. Cool. Well, thanks a lot, John. I guess we got rid of that squiggle. Point and shoot, just like you said. That's super cool. So now I just need to use this compile db make command instead of make. I wonder if I kind of want to make an alias for that. Alias db make. Or can you still just use make? Oh wait, if I ever generate, if I ever modify the files or stuff like that, I probably need to regenerate the compile commands JSON. But otherwise, yeah, otherwise I can just simply type make. Okay, that's awesome. Thank you. So let's keep it moving. I kind of forget what syspage map does. So I'm going to go back. I'm just going to go and read. Damn. We can map a page, a memory in the source, to dest with the permissions perm. Yes. What other is this called? I forget. Mset stats. None of these are relevant. So, okay, let's just go. Wait a sec. But what does this do? Allocate it? No. Map memory at source to dest. And the way that works is what? Given a source, look up the environments. We look up the source VA. We get the page info, we get the PTE. Perm. If we're trying to make it writable and it was not originally writable, we fail. And then we insert an entry in their page tables to point to that physical memory at this virtual address with perm. Okay, that's pretty easy. So we need to, I think we kind of just do something similar to this. Also, hello, I don't know how to pronounce this Japanese name, I believe, but thanks for joining. Okay. So we're allocating into env ID, right? So env ID. With this. And then we're mapping that source, no. Wait a second, no. So in this case, this was kind of weird because we're mapping that back into our process so we can write to it. But in this case, we're actually not going to do that. I think we're going to map, the source is 0, the address is address, the destination is env ID, and the address is address. And we're just I think that's it. Okay. returns so what do these things return? They return errors. The other code was just panicking if any of these things failed. I guess I won't do that. Return 0, return R. I'm actually going to rename this thing to error because I'm renaming it to error because I read the OpenBSD source code and they use the variable name error for this stuff. So I'm just going to assume they know what they're doing. Okay. So I think that handles the simple case. Now let's handle the other case. Read, write, and, well, so if it's read writable, yeah. It's like, what if the cow, maybe I need an assert here actually. I'm going to assert that because it doesn't make sense for it to have a cow bit and be writable, I think. So I'm going to assert that it's like if the cow bit is set, so it's either not, I think, or PT, right? Is that what I'm trying to do? So assert that it's either not cow, and if it is cow, then it also then it cannot have a writable thing. Assert that it is not cow. Not cow. So if it's not cow, it immediately succeeds the assert. And if it is cow, then it must also be not writable. So now over here, now that kind of consistency state of the page table entry is checked, I believe we can just do something like this where it's like if it's either writable or has the cow bit, we just go to here. Because if it has the cow bit, we know that it must also be read-only. What's up, Duck? All right, time for a 20-second break to stand up and stretch. Be right back. All right. I am implementing copy on write in userspace. So, yes. So in this case, yeah, we need to make it read-only. But wait, okay, yeah. We specify the permissions we want. So okay, in this case, we're going to map the page. No, wait, what? We allocate the page to be read-only, just like we always do, right? Actually, wait a second, I'm kind of confused. I don't think I need these page, Alex. I mean, actually, that's literally, it says you should not do this. Here, we're only doing an alloc because we're creating it and then we're mapping it into ourselves at a different place so we can copy it and unmap. But actually, no, we're not allocating. The whole point is to not allocate memory up front. All we're doing is remapping stuff. Yeah, so it's our read-only and not copy on write. We just map from us to them at read-only. If we are writable or we have the cow bit, we map from us to them at pt cow. I believe this is how we do it. Yes. Welcome to all the people that are joining the stream. Thanks for joining. I wonder if this got noticed on Twitter or something. Hombre retweeted us. Thanks a lot to Hombre. Maybe Blue Sky. I've been posting on Blue Sky also, but usually I have not been getting that much traction on Blue Sky. So what's up, GH? Welcome. Okay. Okay, but I'm not doing this right. If the page is writable or copy on write, the new mapping must be created copy on write. And then our mapping must be marked copy on write as well. Yes, that's totally correct. When the fork happens, both sides get write protected. Yeah, I think I'm doing this wrong. This is saying use UVPT duppage, and I haven't used UVPD at all yet. I'm kind of wondering why. What purpose do I have for UVPD actually? But okay, I'm gonna not focus on that. I need to finish this part, which is the new mapping must be created copy on write, and then our mapping must be marked copy on write as well. So that would be here, but the question is, how do I mark the parents how do I modify the page tables for my process, the parent, because we can access the page tables, but only read only. Is there some system call that I forgot about? Sysn. I kind of don't see one, actually. Is it syspage map? Is that possible? That I can modify my own permissions by passing myself as both the source and the dest? That seems kind of strange, but maybe it would work. In which case I would just look up the page in my page tables. I would check that we're not trying to make a writable mapping to an unwritable page. Also, is that... Yeah. And then we would just insert this into our page tables, which would, I think, overwrite if there's already a page map. It should be, yeah. What's up, digitalized? How you doing? Yeah, still on the copy on write stuff. It's kind of a slow process, just taking it step by step, but okay, yeah, can only kind of guess, but I guess I can use this page map to remap stuff in my own process. This is gonna be kind of weird, and I don't have a great feeling about this, but if I just pass 0 on both sides and yeah, like remap it as cow. Yep, more satisfying when I'm done. Yeah, this is actually kind of challenging, but that's what I'm here for. So it's saying if the page is marked writable or copy on write, the new mapping must be created to copy on write. Then our mapping must be marked copy on write as also. So that's what I'm trying to do here. The new mapping from into the environment at address is marked copy on write. And then our mapping in my own process is marked copy on write also. Hello, Zara. Welcome. Thanks for joining again. Yeah, we got a nice little crew of about 10 people in the stream today, I think. Hope everyone's having a nice Sunday. So, okay, this is like, I'm kind of like flailing a little bit here, but so far this is my best guess. And I kind of wonder if there's any way I can test this, but apparently I just need to make things work until I have the fork tree program running. Okay. Must consult the environment for several of the operations. Usually that the PTE for a page is marked PTE cow. And the kernel maps them, uses this trick. And the UVPD is like this interesting thing. I think it's not talked about here. I think it's talked about elsewhere in this file. Thus, the page directory is treated as a page table. Yep. All PTEs can be accessed through a virtual page table at address. The PTE for page number n is stored at UVPTN. That's what we looked into last time. Kind of understood why this works. A second consequence that the contents of the current page directory will always be available at virtual address UVPT plus PT page shift, to which UVPD is set here in. So this thing looks like it's an array, but it's not. It's just a pointer. Well, no. The page directory is an array of page. The page directory is an array of page directory entries. So that would kind of make sense. But okay, yeah, but wait a second. It's like UV plus UVPT shifted 12 times 4. Is that what this thing says? That's not what this thing, yeah, this thing is wrong, I think. Or is it? At least this thing doesn't exactly match this thing, UVPT plus UVPT shifted over 12 times, because page shift is 12. So, but why do I need to access the page directory? I haven't found a reason to do that yet. I haven't needed that so far. But I do remember last time I kind of need to be careful about when doing this array access, because if the PN is not mapped, I think this will crash. Not crash, I think it will cause a page fault exception from the CPU actually. You're only allowed to do this for pages that are mapped actually. And at least in the dumb fork program, they just simply iterated on every single page, which is kind of strange. The strange part is that, somehow that never failed. It's a bit. So what I'm not understanding is, I'm assuming there's just lots of gaps in the user space region of the virtual address space. And when we hit a gap that's not mapped, we're going to call duppage on that gap. And we're going to pass that address into these syscalls. But like, wait a sec, we're calling page alloc on every single one also? Something is a little bit odd about that to me. uText. Okay, that's not even mentioned here. Where your user programs generally begin. uText. There's pretty little information about this, but yeah. So my question is here, I think this is a little bit wrong. The comment here was suggesting that I need to use UVPD. And I think the reason it's saying that is because we might need to first access UVPD to check if it will be safe to access UVPTPN. We can use UVPD to check if there is a valid page directory entry. But I'm still sort of lacking understanding of how to actually use this UVPD thing, unfortunately. So I kind of don't want to, but I might need to go back to all these diagrams to understand this a bit better. Maybe I can do this quickly. So I kind of understood that if we point a page directory entry back at the page directory, what happens then is we can, when we do memory accesses that fall within the range of this page directory entry, something interesting happens, and we can actually start to read the page tables we can read the page table entries for any page in virtual memory, actually. Because we first land in this address space, then we can index back into the page directory, and then we can access index into the page table to read a page table entry. So I understand that basic concept. And now it's time to understand this next part about the UVPD. And it's saying consequence is that will always be available at virtual address UVPT plus UVPT again. UVPT. Oh, I see. Because, wait a sec, wow. Okay, I think I actually kind of get it. So, okay, so first off, in the completely normal scenario, the page walk, okay, 20-second break, stand up and stretch and whatever. Be right back. Yeah, I think I actually, so under completely normal circumstances, the page table walk proceeds through these three different things: page directory, page table, and then indexing into physical memory. That's level like 1. Then level 2, we make this a little bit weird. We point an entry in the page directory back at the page directory. So level 2, it gets a little bit weird. Then the memory walk looks like this. We index into the page directory in this region. We then index again into the page directory, and then we index into a page table and read something there. What this is saying with this whole second consequence thing, so level 1 allowed you to read page table entries. Level 2, to get even more weird, is we don't even have this anymore. We just have this a third time, which is kind of stupid. Wow. We access this into here, and then we access into there again, and then that causes the last step of the memory walk to index into the page directory rather than indexing into a page table. It indexes into the page directory itself, which allows us to read page directory entries also. Oh, that is kind of confusing. So then the question is, how do I actually use? So what do I pass in to UVPD? Yeah, so this is wrong. This is forgetting the ×4, which we can see in the code right here. But I actually think it's kind of the same. You pass in page frame numbers. Yeah. Sorry, I just got distracted by these messages. This is interesting. Cannot be parsed. Include path. Yeah, so that's when I was trying to debug that thing earlier. Okay. So the fundamental way this works, you pass in page frame numbers, which you want to read. So you take your address that you want to query something for. Say you want to get the page table entry of ustack. You shift that to the right 12 bits to get the page frame number, and then you index using that number. And you can read the page table entries. If you want to read the page directory entry for somewhere, you need to, well, I think you could technically do it all with UVPT, but as a convenience helper, they have created the UVPD thing, which points at a specific spot in virtual memory. Yeah. Plus, so this plus UVPT blah ×4 thing means, so the first UVPT gets us here, and then we index and we retrieve these next bits, which get us back here. At which point, yeah, so if we index 0, I think, yeah. So if we index UVPD 0, I think that reads here. And so then what if you have, it's basically just the page, it's literally like the page directory sitting there in userspace, I think. Oh, wow, okay. So I think, so then the question is, what if you have an address and you want to query this page directory? What do? You get its index in the page directory and just pass that in here, I think. Which we have a macro for. It's like the pd index adder uvpd, something like this. So that's kind of my current state of understanding, and I will try to apply what I have learned just now with an assertion. I should probably add some logging here. Oops. Or cow page detected. Yeah, I'm just going to print the page. No, it's got to be in hex. Then, so what I'm going to do is I'm going to look up PDE by attempting page dir index adder. Yeah. Some clever bit manipulation needed here, yeah. Yeah. Did you have a nice time last week learning about bit manipulation? So then, like, I'm just gonna add an assert for the moment. This is like going to fail, but I'm just going to assert that the page directory entry is present. This will fail because there are holes in the space. The access will so need to first check UVPD to see if it's safe. Yeah, it came in handy implements an arithmetic code which does some weird bit manipulation. Nice. So I'm getting kind of spooked out by how I don't actually understand this part of dumb fork. So what I'm actually going to do before I keep moving on regular fork is try to get some more information about this. And if you move run dum, what is it? Make, oh, okay. Sheesh. Ooh, okay. But I don't actually want. Okay, I'll need to fix these anyway. So I'm using Azure wrongly here. Did it work? Okay, I think it still worked good. It's always a bit scary to run these things because I always have the sense I'm going to break things accidentally. Nice, but okay, that worked. I can tell that it worked because this thing does forks a child, does 10 iterations of the print in the parent, and does 20 in the child. That's what yeah, parent exists after 10, child exists after 20. So what my actual question is, we're looping over all these addresses and calling duppage. What are utext? And I'm just going to print these out. Utext. Text. And but okay, does this work? I did not put a new line. Okay, so these programs are very small. So, wow, wait. It's, in this case, the program is only 2 pages long, which is really tiny. That is a teensy tiny process. That's what that is. I want to do a read. Oops. Elf user dumb fork. Yes. Wait a sec though. So the program is loaded at 800,000, which is 2 megabytes. Is it? No, it's 8 megabytes, I think. Wait, what? Kilobyte. Yeah. 1 kilobyte times 1,000 before 100,000, 1 megabyte. This is 8 megabytes. What's up with this 2 thing? It's a read. It's a read. Write mapping. Are there any? Oh, that's what it is, the stab info. Oh, wait, right. The memory layout, I think, talks about this. The stab, which I'm not using at all. And apparently, dumbfork doesn't even handle that. It just completely abandons the stab information, the stab debugging information at hex 200. Okay, so we are ignoring the stab, at least dumbfork is ignoring the stab, and copying the program, which actually is 2 pages in length, although it actually has it skips a page, I think, or actually no. No, the first load segment is more than 1 page in length, and then there's a second page immediately after that, which is very small. Well, the data within it is very small, but it's contiguous. So in actuality, there are 3 pages being used, and they are actually all contiguous. So there were actually no holes in the process. So we're copying basically a tiny amount of information from the start of the uText region, but that's kind of a dangerous assumption to make, that the program is contiguous in memory. I think that is currently the assumption here. Like, if just for fun, if I point this at, let's say, hex 805, no, 5, which is beyond the boundaries here. The current binary stops at like 2000. I would expect to see a panic. The reason I was interested in this, because I was kind of surprised to not have been seeing panics. I was assuming there's all these holes in the address space, but the way the code is written, it passes these invalid addresses into the system calls, which I kind of don't think are meant to, like, when these system calls receive an invalid address or an unmapped address, they return an error code which would cause a panic. But I wasn't seeing any panics so far, so I was kind of surprised about that. We should now see panics. User fault. Okay, that was kind of weird. I didn't expect that. I am not going to take this. I don't know what happened there. I was expecting a panic, to trigger a panic by doing that, but it seemed like it didn't panic, and it simply did a user fault instead. Okay, whatever. I think the main takeaway, though, was that for these very small programs, there are not actually holes. Because there are not holes, it's actually kind of safe to just directly access the page frame number from iterating through this. Actually, this linker thing is interesting. So So this end symbol, so we have a hard-coded load address. We should be able to see this also here. 800,020. And then we arrange for a bunch of the, all right, 20-second break, be right back. We arrange for a bunch of the binaries sections to be loaded at particular addresses. And apparently we can provide symbols. Yeah. That we can then extern from C code, such as this. In this case, the end symbol means the end of the binary, of where the binary has been loaded to. The other thing that's kind of confusing is that this thing says heap, which currently doesn't exist. All we have is program data. And so far it's been totally contiguous. So anyway, okay. In that case, this assertion should actually hold. Because so far we are expecting binaries with contiguous address spaces. So there's no holes, so therefore it's just simply safe to access this. So, okay. So that might be okay. Let me just keep going then. Delete this, delete. So I'm just calling duppage on every one of the pages in the binary, which is pretty small actually, and kind of assuming they are contiguous. I am guarding against that with an assertion, I think, which should be checking for in like unmapped, well, it's checking if we're accessing an address that doesn't have a valid page directory. But what about an address that doesn't have a valid page table entry? That is actually okay, because we're not actually interpreting and going past and like following the chain one level further. So it's okay to query for an address that does not have a valid page table entry, but it's not okay to query for an address that does not have a valid page directory, I think. Which is hence why the page directory is exposed. So I think you can do these kinds of checks, which is what we're doing here. Oops, wow. I just thought of something else that's kind of confusing though, so the problem, like, kind of the key problem is how do we make sure we've mapped and copied everything? Or do we do that by using the UVPD? Actually, that might be the way to go here, because this loop is like, what we're trying to do is just make sure that for every page in use in the user portion of the address space, we make sure to track that somehow and map that into the child. We don't want to miss pages. That would be bad. And so the way the dumb fork worked was it just did kind of a dumb loop using these linker symbols, but that is not very foolproof. That is going to potentially miss any data that is not within this tiny range. It's only going to, it's only going to capture the small piece of memory for the binary image itself. But there could be a lot of other stuff in memory, such as these user stab sections, and it requires all this other stuff like manually copying the stack over. So now I'm kind of maybe getting a sense of what they want me to do. Stack, utop. I kind of am getting the sense that this thing, this hint saying to use UVPD, is telling us to use UVPD to introspect the current state of the process, actually. So we can use UVPD to efficiently determine which pages we need to copy. And the way this is generally going to look, I think, is going to be something like this. But well, first I'll give the naive description. So if we simply have the UVPT array, that still allows this. Okay, I'll do this in 3 levels. Level 1 is the dumbest way. It's the way that dumb fork does it. The dumbest way is to use the linker symbols. This allows us to sort of introspect a very incomplete view of our address space. We can introspect into and learn the addresses of the pages of the binary image that it's mapped in. That's the dumbest way, and the reason it's dumb and the reason it's dumb and kind of bad is because it does not allow learning about any other memory that's mapped in the user portion of the address space. And so the consequence of doing it this way is that you will miss, if the program has mapped data anywhere else, the fork is going to miss it, and that data will not be present in the child. So that's kind of critical. So this is actually not the way to go, I think. So that's level 1, that's the dumbest way. Level 2, which is a slightly better way, but I think inefficient, is to use the UVPT mechanism. And only the UVPT mechanism, and not the UVPD. So level 2 is like, okay, we're using UVPT, we're not using the linker symbols, we're using UVPT, and this mechanism allows us to query the page table entries of any page. So what we technically could do is we could just start iterating from 0 to utop and use UVPT to check every single page and see if there's something we need to copy there. And I think that would work. We just iterate from literally 0 all the way to the top, and we use UVPT array as our oracle for querying whether there's a page. Although wait, no, that actually doesn't work, because it's not safe to access unmapped addresses through UVPT. That is going to cause a page fault exception when it tries to dereference an invalid or non-present page directory entry when doing this walk. So actually that's wrong. I was wrong. It's not possible to do it that way. I kind of thought it would be possible to just iterate on every single page and do the check, but it would just be inefficient. But actually that's wrong, because it's going to like crash when you hit gaps and unmapped regions. So actually, I think the only remaining option is exactly what they have shown here. So the way it is going to look like is you're going to actually iterate on all the page directory entries. And you're going to iterate through the page directory entries to learn about mapped page directory entries. And then for every address, like once you have found a valid page directory entry, for every like address within that range, then you check using UVPT whether that is mapped or not. And then you can do your duplication. But then this way you kind of avoid crashing on invalid, like unmapped addresses with UVPT. Okay. So I think I kind of understand this a bit better now, what they want me to do. Taking a bit of a time, but I think I'm finally kind of coming around to it. So I think this is all wrong. I think this is all totally wrong. Okay, I'm going to respect the process and cow copy any and map all used pages into the child cow, mapping them if necessary. Unlike a dumb fork, we don't just use the linker symbols, which represent a small and incomplete view of the memory used by the process. Rather, use UVPD and UVPT, which are a more robust mechanism which will not miss any pages like the linker symbols will. Okay. Iterate UVPD to locate valid page directory entries. For each valid page directory entry, iterate every page within it and query its status using UVPT. For present pages, do the appropriate mapping. Read only, not cow. Read only, not cow. And then rewrite or cow, read only, and cow. Something like this. We don't need a manual check for the stack now, I'm like dumb fork because the stack will be found in the page tables. However, we need a special case to handle the user space page fault stack to ignore because it should be upfront copied. Okay, this is now representing my view of how to do this. Oh. Right. Well, even though I just realized I was doing things wrong, it feels good to feel like I'm understanding things. Yeah. As now I think I'm a bit on a better path to actually doing this. My mistake was assuming too much, like that I should be basing my solution a bit too closely on dumb fork. It said this is not what you should do, but I wasn't sure what it meant in terms of exactly how much you should not be doing it like this. Okay. So I kind of feel like we should make a function for this though. I'm just gonna call it like do cow, like create child mappings, or create, or like populate mappings in child, something like this. I don't know, I kind of hate naming things. We can touch that up later if we need to. So how did this work again? So actually we don't, I think it might be a void function because we are kind of just, wait, hello? And child. It might actually be a void function because it's like here, we were just relying, in the previous sketched out version of this code, we were just relying on global env ID, right? Env ID comes from here. So we need it to pass in an env ID, which I kind of don't love the name of, so I'm gonna call this child env ID to make that a bit more clear. And I'm just gonna return an int for errors like int error, like a good programmer should. Return 0, and then, yeah. So let's just try to do this. So I need to iterate every entry. Is it 1024? I think so. Every entry in the page dir. And let's see, so well, actually, no. I need to iterate every entry in the user range, which is not actually everything. So I'm going to switch this to a void adder is less than utop, but utop is going to be an int or something. So uint pointer t. and we're going to bump by page size. Okay. And this becomes adder. And then equals UVP VPD page dir index adder. Okay, that is a bit more like it. So then if PD and PTEP, which I kind of, oops, PDE. So we're iterating every address starting from hex 0 all the way up to the top to utop. We're bumping along at every, actually no, this is wrong. We need to bump up by 1. Actually, wait, no, we need to bump up, yeah, by every page size. No, that's right. And we're bumping along, but wait a sec, no, that's the dumb, okay, this is like the stupid way to do this. This is like the not optimized way to do this. This is like the inefficient way, because we're going to have to query every single page, which is what I didn't want to do. So actually, that's not what I wanted to do. What I did want to do, oops, okay. The efficient way to do this is actually to in like go page directory entry by page directory entry, but I need to figure out what is the page directory entry for utop actually, which is not that hard. I really need to make a little Python library of functions to help me with this stuff, because it's kind of annoying to do this every time. But utop is this, and then what? To get the page directory index, you shift by 22 bits. So that is, we don't actually care really what the actual number is, but for the purposes of iterating, I need utop page dir index equals page index utop. Okay, now we can iterate utop page dir index, and now we simply have page dir index goes from 0, page dir index, page dir index, and this gets bumped by 1. So this is optimized. Rather than querying every page, use the page dir to figure out which pages we need to query for. Okay. And yes, so I think, so this is actually, I think, very similar to what it would look like to implement fork in kernel space. When you're in kernel space, you just simply access the page tables to figure out what is in memory. In user space, generally we don't have access to that, except now we do via this UVPT and UVPD mechanism. So we're iterating through every slot in the page directory, and we need to, so we just simply query this page dir index. We simply query this, and then I just kind of feel like checking if it's not present, then continue. right? Actually, I will leave in these things just because I like them. Okay, so if it's not present, continue. If it is present, now we then start iterating through all of the page table entries within that page directory entry range. So we'll get the what's up, Sabi? How do you make Langdy not scream at you because of angle brackets instead of for includes your? Are you using Bear to create? Are you using CHEX and CScope? I am. I am not using Langdy. I am also not using CTags or CScope. I'm using compiledb to create the compile.commands.json, which I only started doing literally today because John Palmisk pointed me out at this actually. But I actually don't really know much about this stuff. I'm gonna kill the palm tree. You probably know more than I do actually. Yeah, I'm using compiledb to create the compile.commands.json. And I'm not using Klingd. Yeah, I'm just using VS Code with the C and C++ extension. But I know like Klingd is super good. I'm just didn't really feel the need to use it, not really being that serious about it. Okay. So void it's like that's a bad variable name, but it's going to be page dir index 22, which is a bad, is number 22? PT shift, that's what I need. Okay. So then I yeah. What is this thing? This is the address. Page dir start v adder. And what? I mean, that could even maybe be inside the loop. Nah, I don't know. I want to just do a simple 1024. Yes, because yes, each of the entries is 4 bytes and they fill a page size, which is 4K. Yeah. Page dir start the adder. So then yeah, then we're iterating through size times I, right? Then we're iterating through every single address within that page dir range. And we are doing what? We are querying the PTE of that address, but we need to shift it down to get the page frame number. And of course, this event pointer T is to be, okay. Okay. Okay, so now we can actually use this for all. Now we can actually do this thing actually. So, and actually we don't need this assert here anymore because we're checking this all in the caller. Actually, no. So now what we need to do is we need to check if PT present. Is that right, actually? Well, yeah, the reason I was thinking about, I was just double checking, is it ever valid for the present bit to be off for a page? I am just thinking about these, like, you know, doing copy, like doing paging out to disk and stuff like that. I mean, I think in that case, actually, yeah, the present bit is marked as 0 to create a page fault on any access. But without that, but I think if you actually do that, you mark the present bit to 0, but you use a different bit in the page table to represent that this thing is elsewhere. So yeah, I think for the moment we can assume that if there is a present bit, then there is something living there, and we need to copy it over. So I actually think then we can call child env ID and pass it this page vadder page size thing. Something like this. However, we need a check. To do handle special edge case for the user space page fault stack. So we need a special case here. Like, I think that will actually go here. Which is just, it's very simple. It's just something like if page vadder equals layout ux ux stack top minus page size, yeah. vadder equals ux stack top minus page size. Then also continue. I could also invert the condition and put this thing into the if, but I kind of don't love that, because this is like a kind of like a pretty uncommon thing to actually hit. So I kind of want to, I also want to reduce nesting of the critical path. So I'm going to just put a continue there, which continues this outer loop. Yeah. Okay. And then, so getting close to the end of time here, but now we're calling duppage explicitly on pages that we've checked are present, both in the page directory and here. So now all we do, yes. So now we can, but the funny thing is actually the calling code here already has access to the page table entry, so there's no reason to query this again. I should actually just rather pass that in, which is starting to deviate from the design of the course actually, but so now I don't need to do this anymore, which is kind of stupid though, because now there's no reason to pass a page. The only reason to pass a page number was to then call this thing with that. Okay, whatever. So, given the current code organization, the caller has already done the PTE check for a present bit and passes the PTE. So whatever, that can be cleaned up later. But then we're just like, okay, we have a given address of a page. We have its page table entry. Time to do our thing. Time to check. Time to assert that the page table entry is in a consistent state, meaning that it either has a cow bit. Wait a sec. Did I? If it. Okay, yeah, meaning that, so if it doesn't have a cow bit, we don't care. What we're trying to test is if it has a cow bit, it also is not writable. So if it has a cow bit, and this thing fails, and then this thing must succeed. So then we just do that consistency check, and then we just do our stuff. So then if it's, we just do our logic. So if it's not writable and not cow, then we just do a simple mapping from us into them. Otherwise, if it is writable or it's cow, then we map it into the child as read only and cow, and to do this, right? And then we then we sort of like tried to update our own page tables, which I don't really understand if this is the right way to do it. That's the only way I can think of we can't use the UVPT mechanism because it's read-only. So this is the only way I can think to do it with the current set of system calls that's exposed. Yeah. But I think it should work. And then that's it. So then, yeah, public mappings in child. And so we're handling don't do page. We need to upfront copy that. Well, actually, I mean, we could also do that here. That actually would be kind of nice, actually. Just like kind of do this one function call that does, like, handles all the normal pages, handles the stack, manually allocates a new exception stack. Let's do it. And so this is going to be another function, and I'm going to call that, this thing is called duppage static int copy page to child. And I'm also going to take an env dt child, oops, child env id, and take a void address, and I'm going to basically copy this thing from dumb fork. Child, oops, wow. Is that right? Yeah. This thing, I'm going to return 0, fail, return error to fail. Oh, whoops. Okay. Copy page to child. And then I'm going to, okay. There's different ways I could do this. I'm gonna do it like this. I'm gonna do it like this. I could do an else there. I kind of don't, I don't know, just didn't really love that. I like the look of this more because this is a very, very uncommon case in the loop. The vast majority of the time we're going to just come through if it's present duppage. And this thing represents this kind of unusual thing to do. So rather than making an else, I feel like personally this makes it a little bit more clear to me that this is intended to be the common case of execution. This is a bit of a unlikely thing. So in that case, we just have our populate mappings in child. All this is junk. Create our child, copy our userspace, and page fault handler setup. What does that mean? Like exception stack? Mark the child as runnable and return. Set the user space. So I did all this already. this, including the binary stack. Doing simple maps, cow maps, or even up front copies as appropriate. The user space page fault stack. And we'll throw in a bit of a const. Why not? Frankly, all this stuff could be const. Const. This is done. What about errors? Does this thing return? This thing returns an error, so we'll do a nice int error equals 0. Return error. Actually, I just realized that up here, we just, this is kind of stupid. We just set this 0 and we return error. Yes. Oof, but actually, and also, wait a sec, no, never mind. This. Also, if we, like, we can allocate a page, but then if this one fails, we need to remember to deallocate the page. Okay. Go to unmap. So first one fails, we just fail out. Second one fails, we need to unmap it, which we do, and then fail. And then if this thing fails, we just fail. Okay. So I don't know. Yeah, this probably has some bugs somewhere. We will just have to find them later. I wonder if I can just run this now though, just to see how it runs. Yeah. This is the question. Set the user space page file handler for the child. What? Is there any information about this? Parent needs to set the user page file entry point for the child to look like its own. How? Oh, is it here? Where the child? Maybe here? So set the page fault handler for the child. I see, I think that does it. So I'm just gonna, oops, oops, wow. Separate project. I am just going to, I need to, do I have a get ignore? Oh, now, okay. Ignore compile commands. Oh, ouch, I just committed all of that, oops. Did not want to do that. your compile commands. Then this, I'm just going to stage all this. And then now I was going to clean some stuff up. So yeah. This comment goes up here, kind of. I don't know, we'll see. I'm just gonna run it and then probably end the stream. Okay, oh shit, I didn't finish page fault. What do I need to do there? Okay, can I just do this quickly? This probably doesn't work. Sure. Wait, what do I do? Checks that the font is a right. If not, okay, so if the error and what was it? FT C. If it's a right and the PTE is not a cow, panic. Page fault from non-cow page. Otherwise, what? Allocates a new and copy the contents, then maps the new page at the appropriate address. Mapped at a temporary location. I think, okay, PF temp. Okay, so this is going to be different from dump work. But I'm going to copy this anyway. And we have a chat. Do we have a? So we're receiving a page fault in our process, which is being deferred to us. We need to allocate a new page map it at a temporary location. I'm going to assume that this is what it means. We're going to how do we copy the data from the old page to the new page? Oh, I see. We just simply read the data. So we know the address. It's like actually in I see. So we had to write, our process tried to do a write to one of these cow mappings. And now we're receiving this in user space. We validate that it's correct, that it's a page fault write to a cow page. We allocate a new temporary page. We copy in from this, from the page where the fault happened into the temp page, and then we're gonna need to unmap the temporary page, and then is it this part? Then we're gonna map what? It's like the source, and then move the new page to the old page's address, meaning this page map takes in the source and then the desk. So the source is going to be and yeah, this is my best guess. We allocate a page at a temporary spot. We copy the data from address into it. We remap from that into the destination, which is map it into address and kind of overlay and overwrite the mapping, I guess. It's marked writable, and then we unmap the pf temp, and then we return. I have no idea if this is going to work. It's probably is not going to work. Okay. But I just want to try to... already have the R, so we don't need that again. 185. Now? Oh, wait, ooh, page size. Page shift. Right, okay. Passing argument 2, 183. So this needs to be, so copy page to child needs what? A void, and this is a UN pointer T. So we get this. Moment of truth. Moment of truth. Yeah, Zara, thanks for hanging out. I'm just trying to finish this all up real quick and just run it. It's probably going to crash, but yeah, moment of truth. 197. Did I do it again? I did it again. Yeah, this speed running, fixing these compiler errors. Error is redeclared here. Oh yeah, okay. Make. All right, moment of truth. How do I run this thing? Tester code with the fork tree program. So what do? Do I do run fork tree? This is gonna crash probably, but wow. Rewrite, okay. Or but those are not. Yeah, I don't know. This did not really seem correct, which is what I expected. But why? Oh, oops. Okay. So this is actually kind of good. It's faulting on a lot of these common pages, which we expected stuff. But then we have, I don't think this is what this is supposed to look like. Yeah, there is a problem. It's supposed to look like what? This. I am blah, blah, blah. We are not seeing that. And so I'm going to debug that next time. Actually, wait a sec. I think I'm going to do some streaming tomorrow. very unusual for me since I only stream on Sundays, but actually I have the day off tomorrow. So I think I think I might stream tomorrow actually. It'll be during the day in Central European Standard Time. So yeah. But with that, I'm gonna head out. Thank you for tagging along. I'm pretty sure a lot of this code was correct. There's just some subtle bugs, which we will need to debug next time. And so if you come back next time, you can watch me do some kernel debugging. So yeah, I'm just going to promote my Discord, which is super quiet to be honest, but feel free to hang out there or we can chat or whatever. Please subscribe to my channel if you like what I'm doing. I stream every week on Sundays. And I'll see you next time for some kernel debugging. Have a great week. See you later.